Okay, don't get panicked yet. Some of you may have not done it. It's fine. So what we will do is this. We will move on, and after class, I will go to each of you guys' computer and make it work. Answer any question that you may have, or you may think you may have. Okay? For now, let us move on. Is this a good deal, Daniel? How about this? Good? Shall we move on, sir?
Yeah.
Okay. Keep your code. Don't close it yet. You can save it, and I will fix it later. Okay. So now you see how it's pretty quick, right? It's pretty easy. But if you have 100 unknown, you have to like inverse or solve system of 100 by 100 matrix. If you have 2 unknown, you have 2 by 2, right? If you have 100, you have 100 by 100. In what kind of situation that you have many unknown? Is there such kind of thing? When you don't know what you're going to do. So let's say you have the data is multi-dimensional data. So let's say you have reservoir data, right? Okay. You have reservoir data, you have cumulative odd production. And then you know, hey, you know porosity, you know permeability, and you think it's related to permeability and porosity, and you have multiple zones, right? And you don't try to do what? Reservoir simulation. You don't do a reservoir simulation, you try to cheat. You try to do curve fitting. So in that case, hey, shall we use porosity? Or porosity square? Or 1 over porosity? Or square root of porosity? Or all of those? Maybe all of those. Shall we use permeability? Or 1 over permeability? Or permeability multiplied by porosity? You don't know, right? So you have many bases for guessing, and you have multiple zones, right? So you end up with many bases. Really, regression model will give you the answer, no matter what you put in. Is that the right answer? Probably not. So we need to use the least amount of bases so that we don't overfit. Okay? Let's look at the concept of overfit. Overfitting is not good. So polynomial regression. Okay, what if I want to do with? So we actually cover this very step by step in a slow fashion, right? So that is what we just have done is use the closed form without using any scikit-learn or anything, right? We just do it manually, kind of manually. Of course, we use like solve system of linear equation. So how can we do it in a better way? So if you want to do polynomial regression, one way, of course, use a closed form solution. If you don't use that, you can create this capital X, okay, easily by use scikit-learn preprocessing import polynomial feature. What it will do is it will take your small x and it will add as many as needed. So let's say you say poly equal to polynomial feature degree 3. So this line itself, it doesn't do anything. It doesn't do anything. It just says poly is an object. Okay? Poly is just an object which have the method for fit transform. Fit transform means it fit and transform at the same time. But you care about that later. So if you say poly, when you create the object, you have the initialization in your object, right? You specify degree equal to 3. What's that? This means, okay, this will create, if you have just one x, it will create 1, x squared, and x cubed. Okay? If you have 2x, it will be combination of those. It will be 1, x1, x2, x1 squared, x2 squared, x1 multiplied by x2, and then x1 cube, x2 cube, x1 squared, x2, x1, x2 squared, x2 squared, x1, or some combination of those until you have third-degree polynomial. Got it? So basically, you can get this table quick. Okay. All right. The question that we just did, we just have x1. We don't have x2, right? You have just one independent variable. If you have two independent variables, it's going to be more fun. Okay, but it can be done. So poly.fit underscore fit transform, it needs vertical vector. So that's why I do x dot reshape minus 1 1. X dot reshape minus 1 1 means make it in a vertical vector. Okay. So poly equal to that means you create this kind of table or this kind of matrix. Okay. So in the code I have capital X consists of x1, x2, x3, x4, something. We will look into that. But basically, once you finish polynomial fit transform, you get this 1, 1, 1, 1, 1, 1, and then you get x. My x this time is from minus 100 to 100 in a constant interval. Okay. And then I have x squared and then x cubed. So third column will be x squared, fourth column will be x cubed, just like that. So that is my x poly. Okay. X poly is like what you did, right? You have x, you have 1 and x. This time you have 1 and x, right? You get my point? What we just did together, we just have 1 and x. But polynomial feature create the rest. Okay. If you have 3 or 4 independent variables, you need x1, x2, x3, x4, multiplication of those, right? But if you do square of those, if you do cube, it will be x1 square x2, x1 square x2, x3, x1 square x2, x4, x2 square x1, x4. There are several combinations. How do you get all combinations? You can, but quickest way is to do poly.fit transform, use polynomial feature. Right? So once you do polynomial feature, you can use xtx. So this way I try to solve it based on like closed form manually. This is kind of manual, right? I do x transpose x like we did. X poly dot t dot parenthesis x poly. So this is x transpose x. Good. And then we have x transpose y, which is x poly dot t dot y dot reshape minus 1 1. Okay. So beta is sp dot lin alg dot solve xtx xty. So I just like solve system of linear equation. Then I get the array, and this thing will be coefficient. Once you did that, what is the next step? You plot. So you see how does it look like. So I also plot. I do it several times. I can have green line. So the big blue dot, that is the given data. Okay. I have the data that's slightly off from the linear trend. Slightly off from the linear trend. And then I fit with first order, second order, third order. I have linear line. Okay. Zero order will just give you the average, will be just a straight line. So I have linear line, second order polynomial, cubic equation, until 8th order polynomial. 8th order polynomial, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points. 8th order polynomial will pass through all points. If you calculate r squared, it's going to be equal to 1. Highest r squared. Is that good?
Not possible.
What do you think? From here that you see, which line is the best for interpolation?
None.
Oh, I would use green line. So if you,
It doesn't pass through that.
okay, your data have noise. You don't 100% trust your data, right? So the data have noise. What do? We use the simple model that can do good. So how I say the gray line overfit. What is my proof? Okay. To show you which one overfit or which one not overfit. How about this? If I remove one dot, and I fit with all of that equation, and I put that dot back, and what is the error? That will tell me like which line overfit. Okay, you see my point? So let's draw something so that you really see it. So let's say I have 3 dots. This dot, and this dot. Okay, or maybe 4 dots. This dot too. So if I remove that dot, I use it as a test data set. I draw the line. If I draw parabola may pass it like this, right? R squared equal to 1. So it worked perfect on the training data set. What about test data set? So I put that as a test data set. Hey, there's a lot of error, right? So even though it performed well on the training data set, it doesn't work well on the test data set. So what about linear line? So if I do just linear line, maybe do something like something like that. Okay. So I don't have this thing to do the linear line. I just have 3 dots. So there's dot, this dot, and I get a line. So it worked okay on the training set. It's not perfect on the training set, but on the test set, it has smaller error, right? So what tells you which model is good? It's not just on the training data set. It's about test data set. So what you can do, one method is you separate 20% of the data out. Never ever look at it. Don't look at it, okay? And you just use 80% of the data, make your model. Okay, whatever you get. So let's say you have 5 models. Model 1 work okay, model 5 maybe work perfect on your training data set. Work perfect means you trust the test data set too much. So you overfit to the test data set, right? And then you try to test which model perform best. What do? So you train your model with the trained data set, right? The 80%. Now it's the time to use that 20%. So you take your 20% of the data out and you check each model against your 20% of the data and see which one perform best. Okay. So the one that get best score on the test set, that's the best model. You see my point? So the one that overfit to the trained data set may not be able to predict the test data set. Question? Question? What are you typing? I will help you do the homework. So right now, please stop, sir. Let's focus on something new. We're going to have tests on that. Don't you like to know more about it? Yeah. You want to know more about it? Okay. So one method is train, test, split. Separate 20% of the data out and use them at the end as a test data set. Use 80% of the data to train the model. Okay. So if your model overfit, model can match or memorize the trained data set very well, but it cannot we use to accurately predicting the test data set, right? So it tries to memorize the trend set, but it cannot do the unseen problem or the test data set. Then this means it's overfit, right? If it's underfitting, this means the model cannot even do the train data set. You get the point? So this same thing will happen to your exam. So your exam, I train you with some kind of information, but in order to test you, if you can extrapolate or you can really do it, it has to be something new. Okay? So don't expect when you have open note, open book, open everything, you can get the seed problem. It won't be a seed problem. Okay? Alright, that is one method of to tell which one overpredict. Okay, how do we split it? When we split, we want to split it randomly, do we? Yes, we want to split it randomly. If you have a curve, like you have this dot, and the actual data is parabola, is from parabola. If you split by, like, you take this part of the data out, what happened? So whatever you train, you get this line, right? You just get this line, whatever you do. And you cannot predict this part. Because when you do trend test split, you didn't randomly remove it. You like intentionally remove important part. None of the model can predict anything, right? So when you do trend test split, remove it randomly. There are several ways of doing it. One easy way is to use scikit-learn. Okay. From sklearn.model selection, import trend test split. So this function will split the data into test and train data. So you have x train, x test, y train, y test equal to, okay, the purpose of that parenthesis is, what's the purpose of that parenthesis? So that I can write something across multiple lines. If you put parentheses, cover it, Python will understand that, hey, there's a continuation in the line. Okay? So 10 trace split x comma y, test size equal to 0.2. So 20% of the data will be used as a test set, and 80% will be used as a training set. Okay? And I put random state equal to 2. You can do random state equal to 5, 10, 62, 42, 52, it doesn't matter. The reason that I put the random state equal to some number is that what I did is repeatable. If I don't specify what is the random state, each time that I run the code, it split in a different way. If I want that, I do that. But I want my method to be like repeatable, so I set the random state equal to 2. Okay, so this way, if you split x into x train and x test, it will split y into y train and y test, right? Okay.
So we can assign any number to random state.
Any number?
Okay, is it just
Integer. 1,000, 2,000 is fine, but integer, not too much.
And do
There's
you
no
really
point.
need to put the data in after the parenthesis in the new line, or you can start from right after?
Each line, you should have no more than 79 characters as per bed 8. Bed 8 is like writing style. Okay. To make your code readable easily, in each line you should not have more than 79 characters.
Is there a limit?
So it's not a limitation of Python, but it helps for you to make the program that have no bug. If your line is very long, you have to scroll it. Difficult to read, difficult to debug. Other people, difficult to read yours, difficult to maintain. We don't like that. So if it is going to be too long, split it into multiple lines.
Is it the random state like Can I say it's like a random seed?
Yeah. It's like a seed. Yeah, random seed. Same thing. Okay. Data leaking and leaking type. Okay, data leaking is dangerous because we may think that the model is good, but when we really use it, it is bad. Data leaking means you use your test. There are several kinds of leaking, but number one, not using the test set at the end. Okay, if you don't use the test set at the end, there's a problem. So the purpose of having the test set is that your model can do extrapolation, right? And there's no point to overfit to the test set. You see that point? So if you know what is a test set, you create your model, you know the performance with the training set, and you know the performance with the test set. And if you do it several times, you can adjust your model such that it works perfect on the test set. And it may work just perfect on the train set. But there's no point of doing that. Okay, that is some kind of cheating ourselves. If you do that, this means your model fit very well or memorize very well on your test set and memorize very well on your train set. So it memorizes test set and train set. This doesn't mean that it will work with real world application. So when you encounter the new thing, it's going to be something else, and it doesn't work because it just overfit to the test set. So the purpose of test data set is not for you to tune your model to match the test. No, it's not that. Because if you ever match to the test set, the real test, you won't pass that when it is in the real world. So in Kaggle competition, it's about machine learning competition. Kaggle provides train set and test set. So there's one person try to fit their model to both train and test set. But guess what? When they really check which model is best, they use another test set. So if you overfit to the test set that you have, you cannot predict another test set that is unseen. So the purpose is to be able to predict the real world application, right? Use your test set just once at the end to check your model performance. Okay? So looking at the test set and do data pre-processing and model the selection. So if you ever take a look on the trends on the test set, this means you try to make your model fit well on the test set. So this is a leak of the information. The test set is supposed to be something that you should check, but you should not know to begin with, right? So let's say we try to predict the price of Bitcoin. Okay, we try to predict the price of the Bitcoin. You have the data, January data, and you try to predict February data. At the time that you do the prediction, you have just January data and you do the prediction, right? But if you ever take a look on February data, so you look from the hindsight, you look at the future, you use the data that is not currently available at that time. Your model works very good, it looks very good, but when you really use it, it doesn't work. Okay? So don't ever look at the test set. Don't ever look at it. Use it at the very end. If you want to do pre-processing data, don't look at the test set. Okay? Adjust the hyperparameter to make a good match with the test set. Not a good idea. No, you don't want to make a match with the test set. Okay, this is one type of leaking. Another type is use the answer to predict the answer. There's no point to use answer to predict the answer, okay? If you do that, or if I do that, I cheat myself. I should not do that. So let's say you have two target values. You have two y. You have y1 and y2. Okay. we should assume that y1 and y2, they are target value or dependent variable. It's something that we want to predict. So, but if I use y2 as input, so I use part of the output to predict another output. That is data leaking. When you actually work in the real world problem, you don't have output, right? You don't have y2, you just have x1, x2, x3. You get my point? So like let's say, I do the experiment. I do multi-phase flow experiment. It gives me liquid hold up and slug frequency. I say, hey, my model, take the input of flow rate and take the input of slug frequency to predict the liquid hold up. If you think about it, it sounds fine, but actually I use part of the answer to predict another answer. There's a leak, because if you ever predict the real application, you will not know the slug frequency to begin with, right? So you cannot use part of the answer to predict another answer. That is data leaking. Data leaking, it makes you think that your model is good, but it's not. Okay? Look from the high side, use the data. Okay, use the data to predict the input. Pre-processing model assumptions are based on the information that is not known at the time of prediction, like the stock price or Bitcoin price. So if you use the information in the future, or your assumption is based on something in the future that is not available at the time of the prediction, you have data leaking. You look from the high side. So everyone can say, after everything happened, you can say the correct thing, right? But you will not know about that at the time of the prediction. Or if you accidentally shuffle the trend set, causing the future information to be available at the model prediction time. Okay. So if you shuffle it, the data on 10 years afterward happen right now. So when you do history matching, or you try to do something like history matching but use machine learning, you have future data to do the prediction. That's not cool. Okay, that's bad. Okay, most of the time.
One question.
Yes.
When you didn't paint.
What is paint?
Yeah. So basically, we had the data, but
We
you
had the data.
extracted the part of the data. Is it data leaking?
That's not data leaking. That is bad way of do trend test split. If you split it, if you split just this part as a test data set and you train your model with this, your model cannot predict that. Not because that it cannot, it's because that you didn't do it properly. Right? So even you should use parabola, right? So if you just give this data, the parabola will be this, but it cannot predict that part. See my point? So when you shuffle,
It will not be exactly like that.
it won't predict if it doesn't know. One classic example is this. I have ping pong ball. I get this from Dr. Gorer. Ping pong ball do this. Bump, 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 bump. Like that. Okay? But if I tell my model, hey, predict the trajectory of the ping pong ball based on the data. And the data that I give is this. Guess what? Any model will predict this line or something like that, right? So the way you do trend test split matter. But when you test your model with respect to real phenomena, which is this dot, right? It doesn't work. Okay? Trend test split work fine if you have a lot of data. But if you have a lot of data, maybe you don't need to do any regression. You just look at the data and you guess, and it's done. If you have limited data, limited number of data, do cross-validation. To do cross-validation is this. It's a way to tell which model worked very good without using the test data set. So So step 1, you separate everything from the test data set out. You take the test set out, never look at it, keep it there, use it at the very end. Step 2, do the cross validation. Cross validation is, let's say we do 3-4 cross validation. We separate data into 3 parts. Now picture, oh, okay, no picture. 3-4 cross validation look like this. Oh. So when you have data, you split it into 3 parts. Okay? You use number 1 and number 2, do the training. And you use number 3 as a test. You get your performance score, maybe R squared. And then you use number 1 and number 3 as training. And you use number 2 as testing. And then you use number 2 and number 3 as training, and number 1 as testing. So you use each part as a test data set 1 time. Right? Once you do all that, this means you have to fit your model 3 times. Once you do that, you average the performance score of each part. Whatever score, average score, that is your model performance. So by doing it this way, what you can do is you make your model best fit to the training data set. Let's go back to this line, overfitting line. You see this? If you do cross validation, you're never going to use 7 order or 8 order polynomial, right? But if you don't do cross validation, maybe I do use polynomial degree 8. So if you do cross validation, you remove 1 point, or you remove, like, if you do 3-4, you remove 1/3 of the data, and you do fitting, right? And then you remove another 1/3 of the data, you do fitting again, you do remove another 1/3 of the data, do fitting again, and then you get average of your test score. Test score can be R squared. Okay. And at the very end, once you fit your model very good with the training data set, then you use test set later. Okay? So this way you don't have to dig. Data in 4.1 use as a test set, data in another 2.4 training the model. Each 4 used as a test set, test score from each training are reported. So that's this one from cross validation score. Okay. It is one function in the scikit-learn. So scikit-learn, sklearn.model selection import cross-wall score, cross-validation score. So this way you can do cross-validation easily. You see this part? This is inside the for loop. In the for loop I say, okay, I try to fit polynomial degree 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 by 1. Okay. Poly equal to polynomial feature, degree equal to dec. So this is pre-processing process, right? Pre-processing. Then I do x poly equal to poly.fit transform, x train dot reshape minus 1, 1. Model equal to linear regression. You have to import it first before doing this, okay? I define my model as an object, which is linear regression object, and I do, hey, CV is K4, n split equal to 5, and we don't do any further shuffle. Score equal to cross validation score of model x poly, x train, and CV equal to capital CV.
Is this CV
Print
doing
score.
the splitting thing?
CV doing the splitting thing, yes. So I split the domain, use K4 method. K4 method just split it into 5 parts. If you do n split equal to 5. So when you do score equal to cross validation score, it do cross validation score calculation. So it set each of your four as a test, or they don't call test, they call validation set. Training compare with the validation set. Training compare with another validation set. Once you get, so I do 9 times, right, or 8 times, from 1 to 8. So I print my cross validation score and score of mean. So degree 1 cross validation score look like that, 0.78. Degree 2, 0.76, and cross validation score go down as the number degree go up. So this way, hey, linear model work best, right? Linear model work best. If you do cross validation, linear model work best. Okay?
Okay, 1 minute. Why did you have to shuffle that? If you go to previous slide.
Shuffle equal to false because we already shuffle it when we do train test split. You don't need to shuffle it further. Actually, if you do CV equal to 5, it's okay too. This just shows some part of the code. We will go over the code too. But this just to show you linear model is best because the cross validation score is highest. Okay. Regularization method. Okay, 1 more minute. Regularization method is same as linear regression. In linear regression, you have just this term, right? If you add this term, do the regression by minimize the sum square error subject to summation of the coefficient less than a certain number. So it's try to select the model that have lowest summation of your coefficient. Okay, so third degree polynomial, you have 3 coefficients. Add them together is more. Like just linear, you have just 2 coefficients. Add them together is less. That is L1 regularization. You do summation of beta, absolute beta. For L2 regularization, you do norm of beta. And L1 and L2, we explain it next time. Okay, it's 12:20. Thank you for coming. We will try to cover more next time. We may not be able to cover everything in the syllabus. I'm sorry about that, but I hope you learned something, okay? The test days is on, November 8th. Okay, bye-bye. And those of you who haven't done it yet, let me go check one by one and see to help you more, okay?